Hello everyone, this is Tim with CPOC, and we just finished an SD-WAN CPOC, a pretty big one actually, and I thought I would take this opportunity to show you guys some of the tools that we use in CPOC to make our demonstrations better. The tools I'm going to focus on for this particular CPOC are WAN-M, which is a WAN emulator. We use it to inject WAN impairment. And of course, T-Rex, which is a traffic generator that I have previously shown on my channel and showed people how to build it. So let's jump right in. And this is a big topology, so I'll try to break it down for everyone so it makes sense. So this is a large SD-WAN topology with a huge data center backbone. So let's start at DC1 here. DC1 is just United States data center. This data center has a connection to a private MPLS and also connection to a carrier MPLS and a carrier service provider. There are also two other data centers, one in the EU and one in APJ, and both of them have similar connectivity to a private MPLS backbone and also to a public MPLS carrier and a internet carrier. They also have connectivity to a cloud provider, and that's emulated via Charlie 12 and Charlie 13 at the top. We're using that as a kind of a SaaS provider. It's connected to web servers running in our UCS. And that's to emulate like an Azure or something like that that has a connectivity into the private MPLS. In the middle there, you can see our two carriers. So we have an MPLS provider. Really, it's just a switch that we're using to emulate an MPLS private circuit carried by a service provider. And then, of course, we have an iNet cloud, which is the same. It's set up as a switch. It's connected, connecting all of those devices, and it's also connecting to our Viptela cloud, which in this case is just a UCS that is hosting the control plane, the vBon, vSmart, vManage for our Viptela environment. At the bottom is kind of a smattering of different kind of branch setups. On the left we have branch 2, which is just a single connected small site. Connected only to the internet and with a switch behind it. We also have EX2, which is kind of an extranet offering, a small where we have a small site where an extranet is being offering some kind of service and just connected directly there to the SD-WAN fabric. We have branch 3, which again is a small site but is dual connectivity to both MPLS and to internet. We have this CIB site, which is dual connected and has two routers, two 4451s. We have this EX1 site where we have more redundant kind of extranet connection where we have two routers with a TLOC extension, one connected to MPLS and one connected to internet. And the last is we have this KCF, which is kind of an outsider extranet contractor type site, which again is a fairly small site using a vEdge 1K, and it's dual connected to MPLS and internet. So that's the basic setup. You can see we also have just kind of a Zscaler, well, not a real Zscaler, but kind of a fake Zscaler where we've connected a router that we can build an IPsec tunnel to from within the lab in order to simulate a Zscaler tunnel. What's also really interesting about this particular setup is that branch 2, branch 3, and the CIB branch are on one service VPN. Then EX1 and EX2 are on a separate service VPN. And then KCF is on a third service VPN. And to facilitate traffic between the three VPNs where needed, we're actually using kind of a shared services firewall setup. In this case, we're not using real firewalls. We're using a router simulating a firewall. And we're using that in each data center. So For the sites that are homed to a particular data center, each one has a firewall advertising the routes into other VPNs for those VPNs that are home to it. So as an example, BR2 and EX2 are going to be forced with an hub and spoke topology to only go through DC2, whereas BR3 will be forced through hub spoke topology to be home to DC3. And then CIB1, EX1, and KCF1 will be homed to DC1. So not only is there inter-service VPN route leaking and traffic here, there's also traffic between the data centers in order to reach from one branch to another through kind of a shared services firewall, which makes this whole setup pretty interesting.